Hello and welcome back. In this lecture, we are going to continue our discussion on quadratic equations. And let's start by looking at some special cases. So, assume this quadratic equation ax squared plus bx plus c equals 0, right? And right out of the bat, we know that the s, the sum of the two roots, is minus b over a, just as a reminder, and the p, the product of the roots, is c over a. Okay, and we can write this expression, this quadratic equation is equal to a times x minus x1, a times x minus x1, x minus x2. This is how you factorize a polynomial, and we already know that this is equal to a times x squared minus sx plus p. Okay, so have this at the back of your mind always. So if one root is the negative of the other roots, so we have a negative sign here, then what happens? Then the sum of the roots is 0, right? x1 plus x2 is basically 0. This means that b over a or minus b over a should be 0. So, this is true if we have two real roots, and the roots are not identical. They should not be the same, because if delta is 0 and we have two identical roots, then the sum is never 0 unless the roots are 0. Okay, and b should be 0. So if I have a quadratic equation that doesn't have the bx term, doesn't have x to the first 1 power, then the two roots are definitely minus each other, because the sum is 0. Obviously delta should be positive. If the two roots are inverse of each other, then the product x1 times x2 is 1. This means c over a is 1. This means that if delta is positive, so that I have two real roots, two distinct roots, then a and c is 0. The coefficient of x squared should be equal to the coefficient of x 0. Okay, later on we see the relation between this and the fact that we can create another quadratic equation whose roots are inverse of this quadratic equation. We can see this. If the second root is the first root plus some constant number k, obviously this means that the absolute value of x2 minus x1 is some given constant k. This means square root of delta over the absolute value of a is k, and k is positive. Let's assume that it's positive. If not, then we know that this has to go into absolute value. If one root it's some constant k, again k is constant, times the first root, then b squared over ac is equal to k plus 1 squared over k. And it's a good practice to prove it. So let's go and prove this. How do we prove this? So what do we know? We know s and p, right? S is minus b over a and p is c over a. These are given. And x2 is kx1, right? And this is our assumption, and we want to know what relations should hold so that this relation can be possible, x2 equals kx1. If we do not have any information on the roots, then a, b, and c can be any arbitrary number, right? But if we establish a relation between the roots, this means we lose 1 degree of freedom, DOF, degree of freedom, on the coefficient. This means there should be a relation between the coefficient, right? Between a, b, and c. We lose 1 degree of freedom. We only end up with 2 degrees of freedom. Two coefficients can be chosen arbitrarily, and this third one should be found based on the relation that is there. All right, so um, how do we prove this? So S is x1 plus x2, which is minus b over a, right? And if we substitute for x2, we end up k plus 1 x1 is minus b over a, okay? X times x2 is c over a, and if we substitute for x2, we end up with k x1 squared is c over a. And if we square the first one, k plus 1 squared x1 squared is b squared over a squared. And the third one is again k x1 squared is c over a. And obviously if we divide them, okay, we basically remove x1 squared by dividing them, and we end up with b squared over ac is k plus 1 squared over k, right? I'm dividing the first one by the second one. So we prove this. Alright, question 49. In equation 1 minus m squared plus 3m plus 1 minus m equals 0. This is a quadratic equation, right? Just by looking at this, you have to realize what kind of problem we're solving. So we're solving a quadratic equation. I'm going to write it down. Yeah. One root is 2 units more than the other root. So x2 is x1 plus k, right? And k is 2. So I'm going to write it down as 2. And since we are establishing a relation between x1 and x2, we lose 1 degree of freedom on the coefficients. But the coefficients only had one unknown, right? One unknown, which is m. And if we lose this freedom, which means m has to be determined. M cannot be any arbitrary number. If m is any arbitrary number, okay, we get two roots. But if we establish a relation between the two roots, then m cannot be any arbitrary number. We're losing that degree of freedom, okay? That's why here we're looking for m, assuming that there is a relation between x1 and x2, okay? So how do we find m? First of all, obviously just by looking at this, we see that the product p is 1 minus m over 1 minus m, which is 1, right? And s, the sum is minus 3 over 1 minus m, so 3 over m minus 1. Now if the product is 1, one root is the inverse of the other, right? So x2 is 1 over x1. You substitute, you create another quadratic equation for x1. So 1 over x1 is x1 plus 2. Therefore, x1 squared plus 2x1 is 1. Make it a complete square. x1 plus 1 squared is 2. Therefore, x1 could be either minus 1 plus square root of 2 or negative 1 minus square root of 2, okay? And then let's continue with x1 equals minus 1 plus square root of 2, x1 equals minus 1 minus square root of 2. Now if we end up with first choice, minus 1 plus square root of 2, therefore x2 becomes 1 plus square root of 2, right? Plus 2. And the product is 1. If x1 is minus 1 minus square root of 2, then x2 becomes 1 minus square root of 2, right? Because you add 2 units. But then so, and then here, what is the sum here? The sum is 3 over m minus 1, right? and here the sum is 2 square root of 2. For the bottom one s, the sum is minus 2 square root of 2. Okay, so m minus 1 is either 3 over 2 square root of 2, 3 square root of 2 over 4. M minus 1 is minus 3 square root of 2 over 4, right? So m is 1 plus minus 3 square root of 2 over 4. Now obviously in the choices you see that we have two choices that only specify one of the solutions here, so that should give us some alarm in the mind at what's going on. So the other thing that we have to check specifically here is that we have to make sure we have two real roots, and that puts another condition or inequality on the range of the values that m can have. Remember, what is delta? Is b squared minus 4ac, and this has to be positive. So 1 minus m has to be less than 3 over 2, right? Or m minus 1. What is m minus 1? M minus 1 is 3 over 2 square root of 2, which is definitely less than 3 over 2. So both solutions are possible. So we choose number 4, okay? So regardless of whether or not m minus 1 is plus or negative 3 square root of 2 divided by 4, delta is always positive. So there is no problem there. Question 50. For what values of m, one root of equation 2 squared minus mx minus 1 equals 0 is minus 8 times the other root. So x2 is minus 8 times x1. And you can see that we end up with the fourth property. One root is k times the other root. And we can solve it. It's easy. I'm just going to substitute. Excuse me.